Hi friends, welcome back to our series of sessions on sensors and transducers. Today let's discuss on photoemissive tubes and photomultiplier tubes. The photoemissive tube or photoelectric cell is a type of glass-filled or vacuum tube that is sensitive to light. Such a tube is more correctly called as photoemissive cell to distinguish it from the photovoltaic or photoconductive cells. Phototubes are previously more widely used but are now replaced in many applications by solid-state photodetectors. The photomultiplier tube is one of the most sensitive light detectors and is still widely used in physics research. This is the photoemissive tube. Normally you have a cathode here and you have an anode, and the photon striking this is the power supply, and this is the other dimension of how it can be seen as a figure. You have a cathode and anode and the power supply for closing the circuit and measuring the current. Phototubes operate according to the photoelectric effect. Incoming photons strike a photocathode, knocking electrons out of its surface, which are attracted to an anode. Thus, current is dependent on the frequency and intensity of incoming photons. Unlike photomultiplier tubes, no amplification takes place, so that the current through the device is typically of the order of a few microamperes. The light wavelength range over which this device is sensitive depends on the material used for the photoemissive cathode. A cesium antimony cathode gives a device that is very sensitive in the violet to ultraviolet region, with sensitivity falling off to blindness to red light. Cesium on oxidized silver gives a cathode that is most sensitive to infrared to red light, falling off towards blue, where the sensitivity is low but not zero. That's the thing. Vacuum devices have a near constant anode current for a given level of illumination relative to anode voltage. Gas-filled devices are more sensitive, but the frequency response to modulated illumination falls off at lower frequencies compared to the vacuum devices. The frequency response of vacuum tubes is generally limited by the transit time of the electrons from cathode to anode. The applications are typically in the controlling temperature of furnace, the automatic switching on and off street bulbs, and reproducing sound in cinematography. These are the typical applications of the vacuum tubes. We normally call them as photoemissive tubes. Now, then coming to photomultipliers, which are typically constructed with an evacuated glass housing using an extremely tight and durable glass to metal seal like other vacuum tubes, containing a photocathode, several diodes, and an anode. Incident photons strike a photocathode material, which is usually a thin vapor deposited conducting layer on the inside of an entry of the device. Electrons are ejected from the surface as a consequence of the photoelectric effect. These electrons are directed by the focusing electrode towards the electron multiplier, where electrons are multiplied by the process of secondary emission. The electron multiplier consists of a number of electrodes. We normally call them as diodes. Each diode is held at a more positive potential by 100 volts than the preceding one. A primary electron leaves the photocathode with the energy of the incoming photon, or about 3 electron volts. For blue photons, a small group of primary electrons is created by the arrival of a group of initial photons. The primary electrons move towards the first diode because they are accelerated by the electric field. They each arrive at 100 electron volts kinetic energy imparted by the potential difference. Upon striking the first diode, more energy electrons are emitted, and these electrons are in turn accelerated towards the second diode. The geometry of the dynode chain is such that the cascade occurs with an exponentially increasing number of electrons being produced at each stage. For example, if at each stage an average of 5 new electrons are produced for each incoming electron, and if there are 12 dynode stages, then at the last stage, one expects for each primary electron of about 5 power 12, 10 power 8 electrons. This last stage is called the anode. This large number of electrons reaching the anode results in a sharp current pulse that is easily detectable, for example, on an oscilloscope, signaling the arrival of the photons at the photocathode 50 nanoseconds earlier. Photomultiplier tubes are typically utilize 1000 to 2000 volts to accelerate electrons within the chain of diodes. The most negative voltage is connected to the cathode and the most positive voltage is connected to the anode. Negative high voltage supplies with the positive terminal grounded are often preferred because this configuration enables the photocurrent to be measured at the low voltage side of the circuit for amplification by subsequent electronic circuits operating at low voltages. See the applications. Photomultipliers were the first electric eye devices being used to measure interruptions in beams of light. Photomultipliers are used in conjunction with scintillators to detect ionizing radiation by means of handheld and fixed radiation protection instruments and particle radiation in physics experiments. Photomultipliers are used in research laboratories to measure the intensity and spectrum of light-emitting materials, such as compound semiconductors and quantum dots. Photomultipliers are also used as the detector in many spectrophotometers. This allows an instrument design that escapes the thermal noise limit on sensitivity and which can therefore substantially increase the dynamic range of the spectrophotometers. Photomultipliers are used in numerous medical equipment designs. For example, blood analysis devices used by clinical medical laboratories such as flow cytometers utilize photomultipliers to determine the relative concentration of various components in blood samples in combination with optical filters and incandescent lamps. An array of photomultipliers are used in a gamma camera. Photomultipliers are typically used as the detectors in flying spot scanners. So these are the typical applications of photomultipliers. So that's all about the photoemissive tubes and photomultipliers as a part of our session on sensors and transducers on Opto Electronic Transducers. Thank you very much.